Yeah, so on this other handout there, what you've got several things. On the top is the course objectives for the final. And what I'd say about those is I've got 7 of them. 1 through 7, I'm going to write them up here, but that's kind of how I arrange the questions. Find limits, find the derivative, solve graphical applications, solve other applications, evaluate Riemann sums. We didn't do a Riemann sum in the little handout there, but that'll be on the test. Evaluate definite, indefinite integrals, and then number 7, use integrals to find areas between curves and volumes of solids. So that's kind of how the final will be arranged. Those 7, because that's what we're supposed to cover. So we'll have problems from each of those. Now, on the bottom half of that sheet, the review problem. So I don't have a review sheet per se on this. However, I picked some problems from the review problems in the book. So these are out of the book, page 97 or whatever starts there. So if you work those, turn those in, when you take the final, those are worth 6 points. It'll be 6 points because the final is 200. So double the point value for those, but they're out of the book. So that's your review if you want to work some more problems, as well as your old test. Review those for some things I'm fixing to mention. So if you look at the back side, it gets a little more specific on the objectives for the final. So these are basically the problems that are on the test. It doesn't have problems on them, but these problems will be the ones on the test. A couple of these we went over with the numbers 1 through 12. We just did those, but some of them I didn't cover. We covered the limits at infinity. Number 2, though, on there, the limits from the right and the left, which that just remind you real quick here. All right, so if I've got this function, say that's 4 right there. We talked about limits from the right and the left because in this case, my limit, let's call it f, as x approaches 4 from the right there, is different than the limit from the left, right? Because the limit, this is being the limit from the right, so the limit from the right would be where the function comes up to from the right. So if I come up from the right, this is coming up to this point, so it's 3. And then the limit as you approach from the left would be 2. So don't forget about limits from the right and left. And then the other thing is for a limit to exist, limit as x approaches 4 to exist, the limit from the right would have to equal the limit from the left. So that's how it, in this case, the limit as x approaches 4 does not exist, right? Because the limit from the left doesn't equal the limit from the right. It's been a while since we talked about that, but that might come up. And then the other thing, number 4, is conditions of continuity. Well, for continuity to happen, you've got to have the limit exist, the function value exist, and those to be the same. So use that to explain discontinuity. So that's number 4, so you might want to look back for those. I didn't do any of those today, but don't have time to. So we covered product rule, quotient rule, implicit differentiation, second, third, higher derivative. Yeah, so remember, not only can you take the first derivative, but you can take subsequent derivatives, third, second, and third. Those mean things too. Sketch the graph of a derivative function. We did remember that. Go back and review that if you haven't done that in a while. Now, as far as remembering formulas, that I think I gave you the actual definition of derivative formula, but you might want to remember that to review that. But number 11 on the objective sheet there, the linear approximation. Yeah, that formula, you might want to remember that. Linear approximation, L of x equals f of a plus f prime of a times x minus a. that's a formula. That's what the linear approximation are. Find the absolute maximum min. Yeah, so then there's the mean value theorem. You might want to go back over those. There's going to be one on those. Newton's method, so there's another formula for you. And I mentioned a while ago, one of the objectives is Riemann sums. Yeah, evaluate the Riemann sum of a function. So remember, Riemann sum, that's just those rectangles. It's the area of the rectangles, either using right-hand endpoints, left-hand endpoints, midpoints. So be familiar with that terminology. But it's just finding the area of those rectangles. Midpoint rule, same thing. That's a Riemann sum, using the midpoints. And come to find out, those rectangles approximate the integral. And so that's what number 20 says, use the midpoint rule to approximate a definite integral. Well, we did several of those. Antiderivatives, done quite a few of those, but area of curves, area between curves, and volumes, those are also going to be, if they're on this sheet, they're on the final. So just be aware there, okay? This method and shell method, so again, probably one of each of those there. So anyway, that should give us plenty to do for the final.